everybody. We are going to talk about density of things, whether it's substances or objects, in this video. Density is the relationship between mass and volume for a substance, and again, or an object. This is generally a topic in which students struggle with, and it's not a difficult topic. You guys understand density. We just have a problem calculating it. And I honestly think that the reason why we struggle with calculating it is because you're really good at remembering some rules. And when you first started talking about algebra and doing x's and y's, you were told you cannot combine unlike terms. And so when you think about density, you got mass, which is in grams, and volume, which is in milliliters. You go, oops, cannot do anything with those. Well, what I need you to remember in science is this: every measurement we have has a value. That's the number, and a unit. So mass has a value, number, and a unit. Volume has a value, a number, and a unit. We are never going to ask you to combine the units. We're going to ask you to divide the numbers. So you're going to leave the units alone and do what the math you know you need to do. All right, so let's go ahead and talk about density. The question at hand here is, how does density relate mass and volume? And what does it actually mean? Well, density certainly just describes how much stuff is crammed or stuffed into a certain amount of space. That's its volume. So how much matter in grams is crammed into a certain space volume. The more matter that you place into something, the denser it becomes. Best example of a densely populated city would be New York City. Lots of people there in a small area. Lots of people. And San Francisco is a very densely populated city. All right. Leesburg, on the other hand, where we live, is not very densely populated. All right. A box filled with feather is less dense than an equal-sized box filled with books. Same volume, different masses. All right. All right. So how do we calculate density? And this comes into that thing I referred to at the beginning, saying, you know, we struggle with this. I'm going to ask you, this is one of my corny little analogies. I wish I could say I came up with it, but I didn't. Take care of my heart. Please just learn the formula and what to do with the units. Density is mass and volume, or divided by volume. Look at the units down below. It says mass is usually reported in grams. Volume is usually reported in milliliters or centimeters cubed. The units for density don't change by doing anything with it. You still have grams divided by milliliters. But what you're going to do is you're going to take the value of the mass, let's say 3 grams, and let's say it was 2 milliliters. You would still have grams per milliliter, but you would take 3 divided by 2, and you'd have 1.5 grams per milliliter. You're going to take a numerator and a denominator, the values, and you're going to do the math by division. Right? That's all you got to do. So the picture over on the right is kind of the corny part. When I tell you to take care of my heart, please don't break it. Or maybe do break it, but break it carefully. Look at the top. The numerator looks like a lowercase m for mass. And there's a division sign, and on the bottom, which is the denominator, you have the volume. So mass divided by volume is density. All right. Okay, so for the next several questions, we've actually got some problems on these. And this is what you're going to want to make sure you take some good notes at, because you're going to be answering these questions in your Google form at the end of the, once you've watched the video. That's going to be your assignment. It's going to be to answer these questions. So as you're going through, take the time to stop and answer the questions. Otherwise, you're going to get to the end and you go, I don't even remember what it showed me. All right. So you got 5 cylinders, and we're going to say the mass for all of those is about the same. I want you to go ahead and give them all a hypothetical mass, whatever number of grams you want, make them all the same number of grams. Your choice. Okay? The differences in the volume, since the numerators staying the same, let's just say 3 grams. I'm just using the same number, but you pick your own. Then the volume is going to determine which object is the most dense. Right? So let's just compare their volumes, which is basically, in this particular case, their heights. To me, it looks like aluminum is about 4 times taller than PB. I'm comparing the biggest one and the smallest one. Since they have the same mass, what do we know about the density of PB if the density of Al is 2.7 grams per milliliter? Remember, density is mass divided by volume. Now again, you give them their grams, and we think aluminum is 4 times taller than lead. See what you can do with this one and try to answer, what do we know about the density of PB if the density of aluminum, which is 4 times taller, is 2.7 grams per milliliter. All right. So we're going to continue with aluminum here. So the next question you're going to see is, if the material doesn't change, we're not talking about different types of material, then the density of the material, left off outward, stays the same. Double the mass, double the volume. All right? Because aluminum is an element, it has a specific density. So the density of the aluminum cylinder on the left is 2.7 grams per milliliter. What would the density be of the 2 aluminum cylinders? It's a multiple choice question. Write it down and be ready to answer it in the Google form at the end. Pause if you need to. All right. There's no question here, but we can determine the density from the slope of a mass-volume graph. Graphing, again, is one of those challenges for some of you, but on the y-axis you see the word mass in grams, and on the x-axis you see volume. And this is just a graph of the mass versus volume data for gummy bears. So if you have mass of gummy bears, it's about 1.5. It means they're going to take up approximately, what does it look like? 5 milliliters? Well, if you increase the mass, it's going to take up more space. So slope is delta y over delta x, which is mass divided by volume. So the slope of this line, which by the way stays the same, is the density. All right. So the easiest points to use would be 0.0 and a point that closely or almost intersects. So I would probably go all the way up there to about the 6 and the 20, because it looks like it's really close to a line. And look and see what you get. All right. I would say the density at the 20 milliliter mark is right about 6.2. So what is the density? 6.2 minus, again, the change in mass versus the change in volume. So you look at, there's the math. And the density of a gummy bear is approximately 0.3100 grams per milliliter. All right, so why are we using 4 decimal places? Well, because when we're doing the math, we have 4 decimal places in our top and our bottom, and our left and our right, and so everything is 4 decimal places. Okay, so what's really cool about density is that over history, some people have used it to their advantage. And this question is one that you're going to want to be able to answer. Just read through this one and talk about these people who, you know, went to see if they could use density to make themselves rich. So be ready to answer at the very end of it after you've read through this. That some folks actually did strike it rich by using density, and what were they doing? Pause, to move to read it as you need to and then move forward. Okay, so let's move forward to another question, and there's a question of this at the end. We have different materials displace different volumes. And so what you have to understand is in the picture on the top, we have a certain volume of aluminum and the density of the aluminum. You have a mass of this particular aluminum is 270 grams. And so what it does is it displaces 100 centimeters cubed of water. Well, the density of water is 1.0. So the mass of the density is also 100 grams. Right? So in this particular case, guess what? The mass of the aluminum, the density of aluminum, is a lot larger than the mass of and density of the water. So what does it do? It sinks. On the other hand, you have this piece of wood in number 2. And when you look at its mass versus volume, you see its density is 0.6, and compare that to the density of water. So the question here is, if you were going kayaking or boating or doing some kind of thing on the water, how would you protect your phone and your wallet from sinking if you were to turn over? Right? What would you need to do? Look at the numbers here and see if you can figure that out and be ready to answer it at the end. All right, this might help you. All right, this might help you with question 8 and also with the question that I'm getting ready to ask you here. It's not listed on here. There is a link on this one to an ice bomb at the top that you're welcome to play with if you'd like to. The phenomenon is this: solid water is less dense than liquid water. How do we know? How do we know that solid water, ice, is less dense than liquid water? What does it take for solid water ice cubes to float? Why is it that they float? So that's the question. Why is it that solid water floats? Okay? Kind of gave you the answer there, but I need you to put it in your own words. All right. So this last slide had to be changed because you can't hear the story otherwise. There is a link. This is a YouTube video that is really cool, just to go to Archimedes and the Golden Crown, and you get to watch this video. It's about 9 minutes, and so this can be done, you know, kind of sort of at your leisure. It does not have to be done, but it's a really neat story about how density causes someone's life to change. All about Archimedes and a golden crown. You can kind of look at the picture at the bottom. Again, it's a 9-minute video that does not have to be watched before you do your Google form. Okay? Thank you, guys.